Additional parameters that can be coded on the job card include the condition parameter, which allows us to test various condition codes from steps, our restart parameter in the event that we need to restart the job at a particular step, and a type run parameter that allows us to handle some execution for holding as well as scanning JCL. These parameters will be discussed in subsequent modules as we get more details on how we can construct a job stream and dealing with steps and multiple steps. So for our purposes right now, we just want to introduce the fact that these parameters exist, but they will be reviewed in more detail in subsequent modules. There are additional parameters available beyond those that we have mentioned already, and any additional review that you want can take place in the MVS JCL reference manual. Be aware that there are a lot of parameters that can be coded, but they are rarely, if ever, used. And as a result, we haven't presented a lot of these more obscure parameters simply because of their low prevalence in the actual runtime environments. So, to take a look now at a job statement based on the information that we've already put together now, we can see that we have our //. The name for our job is called test job 1. We have the job operation field indicating that this is a job statement. Our accounting information indicates just 9654. The programmer name field simply indicates programmer in single quote marks. We don't need them in this case, but it does no harm if they're coded. And then we have two positional parameters, class equals A for our initiator input class, and message class equals X, indicating the output class that we want messages and output data to be sent to. So this is a brief example of a sample job statement that we would use to identify a unit of work. Here's an example of the way it might look in the system, as well as if you have errors in terms of coding the job statement. In this particular instance here, we can see statement 1 is our job statement, and what we have is that the message level parameter is coded incorrectly. It's spelled incorrect. And so we can see at the very bottom of this display, we have a message indicating that we have an unidentified keyword. He's indicating that he doesn't know what this MSG LVEL means. And so when we look at that, we can see that it is spelled incorrectly. So correcting the spelling and resubmitting the job would allow it to run then without errors. In this particular example here, what we have is that if you look at statement number 2, you'll notice that the operation field says JB instead of job. That means that the system cannot recognize that that's a job statement. However, since we've submitted it from TSO, what the system will do is it will automatically generate a default job statement on your behalf. And you can see we have a comment there indicating that the job statement was generated by submit. And so that means that now that we have a valid job statement, when we check the syntax, we see statement number 2 and 3, which represents the job statement with the error in it. And as a result, that's identified as having an unidentified operation field. In other words, JES syntax checking is saying, I have no idea what this means. So that's why we have the error. Again, if we correct statement 2 to make sure that JB spells job, we can submit it again. The system will not generate a job statement, and then everything will run correctly. So this is an example of the type of errors that you can get when you're dealing with a job statement. Now, let's take a look at a demonstration here of, again, using IEBGenner. And what we will do now is we will look at the IEBGenner job that we used in the last example, and this time examine the job statement itself, so that we can see how this is set up and the role that this plays in submitting the background task. Let's take a look now at the IEBGenner that we used from the previous unit and examine what the job card looks like in this particular situation. You can see the name in this case is GATOM2W, and this reflects the user ID plus one additional character to make the name unique from my TSO user ID. You can see the job operation field highlighted in red, and then you can see the accounting information and then the programmer name field in white. Now, this particular installation does not require the accounting information nor the programmer name field. So essentially, we're free to code whatever we choose in that value. And so in this particular case here, this is just an arbitrary string of letters and characters that have been put in there to indicate what type of information can be there, but it has no meaning and it will not be checked for syntax or validation. The first keyword parameter that we have is the message level, in this case indicating message level equals 1. And again, we are dealing with installation defaults that have a message level of 1, 1. So specifying this effectively is going to be ignored because of the fact that the 1 is already prevalent in terms of the statements, and so we will also derive the default value then of the 1 for the messages. So in this case, having this value coded is actually redundant from the system defaults. You can see the comma coded at the end of it, indicating that we are continuing our parameters on to the next statement. The next statement in this case again begins with the double slashes, identifying it as a JCL statement. Then we begin our next set of parameters before position 17, and here we have a message class equals V. This is the designated output class for hold output and stuff that we can view online. So that's the value that we've chosen for that. The notify, in this case, is using the symbolic substitution. So no matter who submits this job, their user ID would be substituted in this notify field, and they would be the one notified when the job completes. And then finally, the parameter class equals 3 indicates the initiator that is designated to pick up class 3 work and run it. So if we go ahead and submit this job, one of the things that we'll be able to see then is that we'll be able to see the message indicating that the job has been submitted. When we get this message here, this is a result of the notifying this particular user ID of the job's completion. When I go into SDSF to actually take a look at the data, I can do a few things. I can look in the system log, for example. We can see the messages in the system console indicating that this GATOM2W started. We can see the initiator designation here. We can see the message indicating that the job is ended, and then we can see the notification message being sent back to the user ID. So this indicates the fact that the job has started and the job has ended. When we go to look at the output itself, you can see then that we can come here and take a look at the output, and in this particular case then, we're going to see all of the information from the JES log to the JCL to the messages and things that are associated with this particular job having been run. So this basically rounds out our discussion about the role of the job statement. Once you have a job statement coded, depending on your installation standards, you will likely be able to use that job statement in virtually every job that you ever submit. So knowing the standards and having a job statement coded is an essential element of building up your library or your pool of JCL statements that you can use to run work. So with that, we'll now move into the third module where we will discuss the execution statement.